Okay, people, let's do simultaneous equations, not least because they're coming up on your mock exam. Right, two things that may well put you off today. You hear any banging tunes, because I've got Martin Garrix upstairs on FL Studio, and you got my ugly face down in the bottom, so ignore that shiny head. Every time I move my Surface Pro, okay, you'll probably get half a shiny head, so try and ignore that. It's there due to popular demand. Okay, so simultaneous equations. We've got two equations. They're simultaneous. They happen at once. We have to solve them together. Okay, we've got to find an x and a y that fit both equations. Let's call this equation 1. Let's call this equation 2. Right, job number 1. My coefficients are not the same. I've got 4x here. I've got 1x here. They're not the same. I've got 6y here. I've got 2y here. They're not the same. Okay, so our first job is to get the x coefficients or the y coefficients the same. Okay, how can I do that? Well, I'm thinking I could times the bottom equation by 4. Because if I do that, I'll get 4x. I could times the bottom equation by 3. Because if I do that, I'll get 6y. It doesn't matter which one of those I choose. Okay, I either need to get 6y, because I've got 6y here, or I need to get 4x, because I've got 4x here. Okay? Let's get rid of those. Which one shall we do? Which one shall we choose? Right, I'm going to do equation 2 multiplied by 3. Just because I feel like it. Okay, so that means we have to multiply every term in that equation by 3. So we're going to rewrite equation 2 underneath. I reckon that's going to give me 3 times x, which is 3x, plus, would have been clever to do the two equations in different colours, wouldn't it? Idiot amps. Right, we've got 2y times 3, that's going to give me 6y. And we've got 5 times 3, that is 15. So this is equation 2, rewritten. Okay, and I'm going to copy equation 1 exactly as it was before underneath. I've got 4x plus 6y equals 16. Okay, so this is good because we've now got 6y and we've got 6y. The coefficients are the same. So, what next? Well, in my y's with the coefficients of plus 6 and plus 6, I notice that they are both pluses. We have the same sign here and here. Okay, and when I've got the same sign, I need to subtract. Okay, we will see why in a minute. So same sign, subtract. Let's go. Okay, now I could take away this equation from this equation, or I could take away this equation from this equation. Does not matter as long as I'm consistent. But I notice that if we look at the bottom equation, we've got 4x. So, I'll put an equation 1 there. So it might make sense to do equation 1, take away equation 2. Okay, because that's going to be a little bit easier for me. So I'm going to do 4x, take away 3x. So 4x take away 3x, that gives me x, 1x. I'm going to do 6y, take away 6y. That gives me nothing. Okay, that's the trick. That's why we need to do it, so that our y's disappear. I've got to do 16, take away 15. Oh, that's so easy. We're done. X is 1. This is a nice easy one. X is 1. Okay, so we found out x is 1 for both of our equations. We now need to substitute x is 1 into one of our equations above to find out what y is. So let's have a look. Right, so I can put it into either of the equations at the top. I'm going to choose the simplest one of equation 1 or 2. And 2 just looks simpler to me. It's only got an x in it, it's got a couple of y's. So we'll write that equation out again. We get x plus 2y equals 5. Okay, but now we know what the x is. We know x is 1. So we take that 1 and we substitute it. We put it in there. So our equation becomes 1 plus 2y equals 5. Right, so now we've got a normal equation to solve. We've only got y in there. We've only got one variable. So I think we're going to take away 1. We're going to subtract 1 from both sides. That's going to give me 2y, because the 1's gone, equals 5 minus 1. I think that's 4. Okay, 2y equals 4. So we can divide both sides by 2. It's going to give me 2y divided by 2 is y, and on this side 4 divided by 2 is 2. So we're solved for y. Okay, so I reckon the answer to these simultaneous equations is x equals 1 and y equals 2. But what if you're wrong, idiot amps? You've already made one mistake. We should check our answer. Okay, so we are now going to substitute x equals 1 and y equals 2 into both equations, just to check. So our first equation, equation 1, too chunky. Okay, our equation 1 was 4x plus 6y equals 16. Okay, so we'll put in, well, we know x is 1, so 4 times 1 gives me 4 plus... you can't even copy from the equation before. That was a y. 4x plus 6y equals 16. That was our equation 1. Okay, so 4 times the 1 gives me 4 plus 6 times what was y? Y was 2. So we've got 6 times 2, that gives me 12. Ooh, this is good. 4 plus 12 gives me 16. I think I might have got it right. Okay, let's substitute into equation 2. Now by now you can assume you're probably right. On an exam we might not have time to check the second one, but let's check. We've got x plus 2y equals 5. Okay, so we're going to try our solutions. X equals 1 plus 2 lots of y. 2 times 2 is 4. Ooh, fabulous. Okay, so if our x and our y value work in both of our simultaneous equations, woohoo, we have solved the simultaneous equation. Okay, let's do another one. I hear you cry. This is fun. Okay, so we've got 2 more simultaneous equations. 7x minus 6y equals 17. And 2x plus 3y equals 19. Right, let's have a look. Well, I'm looking at that second equation, thinking if I multiply it by 2, I should get 6y. And it doesn't matter if the signs are different, okay, as long as my coefficient numbers are the same, we're good to go. So I'm going to try that. I'm going to write out equation number 2, and I'll multiply every term by 2. So 2x multiplied by 2 is 4x. 3y multiplied by 2 is 6y. And 19 multiplied by 2 must be 38. Okay, and just like before, we'll then copy our equation from above, equation 1, exactly as it was. 7x minus 6y equals 17. Right, now this time I noticed that it's, again, my y is where I've got the coefficient the same, but the sign of the coefficient is different. Here we've got plus 6y and minus 6y. And when those signs are different, we need to add the equations. That's really important. We'll see why now. Okay, so let's try adding those equations together. So term by term, or terms by terms, we've got 4x plus 7x, and make that 11x. And here we've got to do the slightly trickier 6y plus negative 6y. Let's just write that on the side for a minute. We've got 6y plus, we're going to add it to negative 6y. Okay, well that's really like saying 6y take away 6y. They're the same thing. Okay, this plus and this minus, it's going to be 6y take away 6y. We think about a number line with a 0 in the middle. Okay, we've gone up to 6y. Y's are on the line. And then we've got to add a negative 6y. If we add a negative 6y, we're going backwards on our number line. Okay, we're going to get back to 0. Alright, if we took away these, it would not work. We'd get 6y, take away a negative 6y. Ooh, 2 negatives. It looks dodgy. 2 negatives. Going to give us a plus. That will give us 12y. That is not what we want to do. Okay, we want to add these two together, and that's going to definitely give me 0y. Nothing there. Okay, 38 plus 17. Oh, that's 55? I think that's 55. Right, so what do we got? 11x equals 55. So this time I need to divide both sides by 11. That's going to give me 11x divided by 11 is just x. That's what we want. 55 divided by 11. It's going to give me 5. So I think x is 5. Okay, so the first part of our answer, x equals 5. So what do we need to do now? Just like last time, we need to substitute that known value into one of our equations. So which one looks easier? 2x plus 3y. I'm going to take equation 2. Try and copy it down properly this time. 2x plus 3y equals 19. And we think that x is 5. So we're going to substitute that into the x part of our equation here. So 2 times x is 2 times 5, that gives me 10, plus 3y, we don't know y yet, equals 19. Okay, I'll look at my left hand side, I'll think, well, I want to take away, I want to subtract that 10. So, subtract 10 from both sides. That'll give me just the 3y on the left, because the 10's gone, and 19, take away 10, it's going to give me 9. Okay, so if I divide by 3, 3y divided by 3 is going to give me y, that's what I want. 9 divided by 3 gives me 3. So I think the second part of our solution is that y is 3. Let's just do a quick check back like we did before. If we're right, we can substitute both of those values in. So let's try with our first equation. 7x minus 6y equals 17. So we think x is 5, 7 times 5 is 35. Take away 6y, so 6 times 3 is 18, so minus 6 times 3 is minus 18. Does that equal 17? 35 take away 18? I think it does. Brilliant. Let's try the second one. 2x plus 3y equals 19. That's a 3. That's a 3. Okay, so 2 times x, 2 times 5 is 10, plus 3 times 3 is 9. Yay! Gives me 19. Excellent. So we were right. Our solutions are x equals 5 and y equals 3. Okay, here's another example for you to have a go at. Pause the video, see what you can do, and then have a look at my solution. Good luck. Okay, how did you do? I got that y equals 3. I did y first, and then I substituted y equals 3, and I got x equals negative 3. X equals minus 3. Okay, now there are a couple of things that if you didn't quite get that, you may need to check. Okay, hopefully, maybe you decided to multiply equation 1 by 2 like I did. That gave me this equation here. Okay, if you used that method, hopefully you then saw that it was the x's that the coefficients were the same, and they were both positive coefficients. I've got the same sign, so I have to subtract equations. Okay, that gave me this 5y equals 12, and now I've got to be really careful. 4x take away 4x was nothing. 8y minus 3y was 5y. I've then got to be really careful. I've got to do 12 take away negative 3. And those two negatives there, a negative and a negative, gotta remember they give me a plus. Okay, so 12 take away, 12 subtract negative 3, that's the same as 12 plus 3, it's 15. Okay, so that's something you may need to watch. Alright, second step, when I've substituted in y equals 3, okay, we've then got an equation over here that says 2x equals negative 6. To get that, I subtracted 12 from both sides. That means that on this side, I can't do 12 take away 6 just because it's a nicer calculation. I'm having to subtract the 12 from the left. That means I've got to do 6 minus 12 on the right. Okay, that gives me negative 6. That gives me this negative 6 here. Okay, so that gives me 2x equals negative 6. Divided by 2, x must be negative 3. Okay, right, hopefully that will be of use. We'll have a look at some more difficult ones next time, maybe with some fractional answers in, and perhaps look at some different methods to solve these. Okay, if you need some practice, revision guides, get them out, find the page, do some. Best of luck, see you next time.